Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the synthesis of glycosylidine diazerine. So that type of the derivative we have discussed yesterday with the some of the suitable example. What we are going to discuss today here, let us look at here the synthesis of glycosylidine diazerine, that type of the derivative. Some of the example we have seen yesterday, starting from the starting material we have arrived or we have obtained the structure of diazerine. If you see the structure, if you observe the structure carefully, there you will find there is a 3-member nitrogen containing double bond at a anomeric carbon atom. So that type of the derivative is known as a glycidine diazerine derivative. Let us talk more about, or let us discuss details about that remaining derivatives, how we can get over here. Let's see over here the another way. Yesterday we have seen, taking as an example the compound at anomeric carbon atom, there is a hydroxyl group present and the bonds with that hydroxyl group is shown by zigzag, or what we can call it in a staggered way, means the configuration of that particular hydroxy group is not assigned definitely, means either that hydroxy group on alpha side or the beta side. If you consider the structure according to the Haworth projection formula, so that is the one thing you should remember, and that anomeric carbon atom is very significant, because at anomeric carbon atom it having hydroxyl group, it is going to go on changing whenever we are adding the reagent, and at last we are going to get the 3-membered nitrogen containing ring, which is nothing but as a diazerine ring. So that is the main focus, main point of discussion, that is the derivative. And that and other hydroxyl group, as we know that they are present or they are lying at equatorial position, that hydroxyl group are protected with benzyl chloride. And now here one more thing is, remember here at a carbon number 2 there is a the hydroxyl group which is protected by, that is what we can call it as acetylamine group over there. So that is a small change you must remember here. Let me recall that first structure here. So this is the structure, again this is anomeric carbon atom and the bond is showing in a this way, that is nothing but that hydroxyl group. We are not sure about that hydroxyl group, whether it is alpha or the beta, and that's why it is shown like this. And now the remaining groups, they are protected by benzyl group OBN, here also OBN and here OBN, which are lying at equatorial position. One more point, noticeable point over here. Here if you write as a OBN, again protected hydroxyl group with benzyl, that become as a structure number first, and that structure number adding with that reagent first, getting as a structure second and the third with the variable quantities, that then that third structure treated with the reagent number second, the structure number third will be converted into as a 4, and that 4 structure treated with reagent number 3, we will get the structure number 5, and that structure number 5 treated with the reagent 4th, we will get the structure number 6, and that structure number 6 will be treated with the reagent number 5. Finally, we will get the structure number 7, which is nothing but as a diazerine derivative. Up till now, and what are those reagent? What is the reagent 1? What will be the reagent second? What will be the reagent third? What will be the reagent fourth? What will be the reagent 5? All these reagents we have seen how much percentage of the product we are generally getting, that also we have seen with the help of suitable example. Now also in the same way we are going to derive, we are going to obtain the another structure, which are the glycosylidine diazerine derivative. Let's see, let's start over here. Now the changes you remember here N, H, and then acetyl group, right? And this structure we can call it as a structure number 8. Up to the structure number 7 we have discussed in detail. Now the structure number onward 18 to 14, today we are going to discuss that protected amine group over there. So that is a change over here. Now this reagent is this compound, this structure number 8 further treated with reagent number 6 over here. Reagent number 6, what do you get here? So you are going to, and as we know that look at this part of this organic compound, the ring is get opened from here, and after opening this ring, what do you get here? Let's see. Here we are going to get, this is a structure which I am showing over here, double bond NH, then OH, that is oxime type of the derivative. This become as a OH. After opening this ring at anomeric carbon, there is a carbon nitrogen double bond NHOH, that is a oxime type of the derivatives obtained, and the rest part of the organic compound, it remains as it is. So you can write it as it is, OBN, then here also OBN, then here also OBN, and now this group also, and all these remaining groups are lying at equatorial position, so you can show it properly. And this structure, now this is the structure number 8. When we added the reagent number 6, what is that reagent number 6? After complete the scheme, after completion of this scheme, we are going to see the details of that reagent, what type of the reagent we are going to, what are the reagent, what do you mean by the, or what do you mean by the, or what is the reagent number 6. So that reagent number 6, detail of that reagent we are going to learn shortly after the completion of this scheme over here. And this now, what will be the structure number? This is the structure number 9 over here, and this structure number 9 at an equilibrium, this is the arrow This arrow clearly shows the equilibrium arrow, means this structure and that structure number, suppose as a structure number 10, they are interconvertible at an equilibrium condition. And what is going to happen over there? See, observe the structure carefully. Then there is a ring formation. Then here will be the here we can draw the double bond N, and here is a OR. So that is the not double bond, here only as a what we can call it as here. This is a ring formation there, NH and the R. NHOH, not R. NHOH only, the ring formation. Only what is going to happen, look at here, this double lone pair which is present on the hydroxyl group is going to attack over there, this double bond, bring that hydrogen atom over here. So here is not the, please remember, make the correction over here is a NH and the OH, because as we know that nitrogen has a 3 bond only, double bond here and one another bond with that hydroxyl group. So that satisfy the bond here, and now after that this is going to attack here like this, and this ring get open, one of the hydrogen atom transfer from here to here, and we are going to get as a this structure, and this structure is nothing but as a structure number 10. Now see the other part of the organic compound, they remains as it is. So you write down as it is over here, and all these groups are lying at equatorial position. So remember that also here is a acetyl group, that amine group is a protected amine group. Now look at this one. Now structure number 10 further treated with the reagent. What is that? Reagent number 6. Now is a reagent number 7 over here. See, this is a reagent number 6. Now I am adding the reagent number 7. What I am going to get over here? Now this part only, remember the anomeric part is gone changing while adding the reagent, and as we know that side is the reaction side, and reaction side is nothing but as a functional group. That functional group at a particular position, that particular functional group is only gone changing. Please remember or please note down that one carefully here. Now what is going to happen here, when we add the reagent number 7, we will be getting the product. Observe this product carefully here. Now the changes are here, double bond N, and here is a OR. Remember here OR. And now other part of this organic compound remains as it is. So write down as it is. All these groups are lying at equatorial position, so you can write down as it is OB, not here is a NHAC. That also you have to carefully note it down or remember. Now this is a structure number 11 over here. Now this structure number 11, when it is treated with the reagent number 8, it will produce or it will give the structure number 12 over here. And what will be the nature of R? If you consider here R is equal to hydrogen atom, that will be the structure number 11. When that structure number 11 added the reagent 8, we will get structure number 12, and where R is equal to nothing but as a TS. TS means what? Tosyl group, and that are the structure we have learned there. And that structure number 12 now, it will be treated with the reagent number 9 over here. Look at these numbers, is nothing but as a reagent, and that I already told you that reagents, details of that reagent after completion of this scheme, this structure, we will see that one. So but here what is going to happen, this structure is going to convert into the product you will get over here, this one. Now there will be a 3-membered ring, NH, these 3-membered ring containing nitrogen atom after the addition of the reagent number 9. And look at once again, write down the group which are already present in those compound. They all are present at equatorial position, and as we know that equatorial position, the bulkier group prefer to stay at equatorial position. That is the basic principle you should remember while representing, while writing as a such type of the compound. Now this is a structure number 13, right? So this is a structure number 13. Now look at, if you observe this structure, the noticeable point over here, at an anomeric carbon atom only the changes are occurring, and finally this 3-membered ring, that is the structure number 13, when it is treated with the reagent number 10, it produces the product, this one, and which is, what is this? The product must be this one. And look at this 3-membered nitrogen containing compound, which is the diazerine. Look at this part. This is the noticeable part you should notice over here, and the rest of the compound, rest of the group, you can write it down as it is. They were present at equatorial position, so you write it down as it is, NH, acetyl group over there, and this is the structure number 14, and that structure number 14 is called as a glycosylidine diazerine derivative. This is called as a glycosylidine diazerine derivative, diazeриne's derivative, this one, and which is a very prominent or the significant as far as this synthesis of glycosylidine derivatives is concerned. And now we got this glycosylidine diazerine as a derivative, which we are going to learn the application, how it will be utilized for the synthesis of other derivative, and how that other derivatives are significant. They exhibit, they shows the biological activities such as antibacterial, antifungal, anti-malarial, anti-tumor, anti-cancer, antioxidant, anti-inflammatory, what we can call it as an oxidant. So that type of the what we can call it the biological activities are determined by the different methods. And now here, what are the reagents of 6, what is the reagent of 7, what will be the reagent of 8, what will be the reagent of 9, what will be the reagent of 10. The details of that reagent now we are going to discuss over here, and now we are going to study right now here. So let's see those reagent in detail. Here now is a reagent number 7, reagent number 5 up to that we have seen yesterday. Now is a reagent number 6 will be sodium metal. This one is a sodium in presence of methanol, sodium in presence of methanol, then NH3OHCl, ammonium hydroxyl chloride will be the reagent, and that is the structure number 8. Then it is heated near about 33 hours at 60 degrees centigrade. At 60 degrees centigrade, the product which we got, that the quantities of that product are yield are variable. That is a quantity which we got will be the variable. That is a structure number 9 and 10. Variable ratio of structure number 9 and the 10 we got over here. Sodium metal treated with that methanol, then ammonium hydroxide chloride, that is the structure number 8, is treated with this reagent, and this mixture or the reaction mixture is heated at 60 degrees centigrade near about 33 hours, and we got the quantity of that yield of that quantity or variable ratio of 9 and 10. That is we are getting in a variable ratio, the 9 to 10. Now is let us see as a reagent number 8, reagent number 7. The reagent number 7, as usual, NaOAc, that is a sodium acetate, and further it will be treated with NaIO4, that is a sodium periodate, and the mixture of the solvent is used ethanol in presence of water, and the compound is heated at 15 degrees centigrade near about 18 hours, and the percentage of yield is obtained. The 70% yield will be obtained by this reaction. Then the structure number 9 and 10, when it is treated with sodium acetate and sodium periodate by taking as an solvent of ethanol water heated at 50 degrees centigrade near about 18 hours, the yield of the product is obtained is a 70% yield is obtained. Now let us look at as a structure number 8 over here. Now the structure number 8, it is used as ET-thrione, means triethylamine. It is an base. Further it is treated with TSCl, that is a tosyl chloride, and it will be that 3 hours 0 degree centigrade, and the yield is obtained near about as a 100% yield is obtained by this reagent when the structure number 9 and 10, when it is treated with this, we got as a 70% yield, and the structure number 11 further treated with this, we will get the 100% yield. And now the next point we are next one, structure number, here is a 9, sorry, not structure number 9, that is a reagent number 9. What will be the reagent number 9 here? That is a saturated ammonia, NH3, then saturated ammonia in methanol, saturated ammonia in methanol, MEOH, then it will be kept for 7 days at an temperature minus 20 degrees centigrade, and the calculated yield is obtained once again as a 70%. So the last reagent, the reagent number 10, what it is once again etithrician triethylamine, then I2, iodine is a reagent, and that the solvent used here, mixture of DCM and the methanol, and stored heated for 3 hours at 0 degree centigrade, and the percentage of this product achieved near about a 68%, that is from 12. So this is all about the how we are getting as a diazerine, and these are the separate reagent I have shown over here. I hope you might understood the what do you mean by glycolidine diazerine derivative. And now what is the next point? Next point we are going to discuss over here how that diazerine derivative further diazerine we are now going to take as an starting material, how it will be utilized for the further achievement of different derivatives. Let us see one suitable example over here. There is a mechanism, but for details of that mechanism we are not going to see over here, but let's see the example means application of this derivative, where it can be used and what type of the product we will get over here. Let's see here, as we know that the diazerine derivatives, this one, where there is a diazerine derivative, remember this is a very noticeable point. At anomeric carbon atom there is a 3-membered ring containing nitrogen double bond, and the other groups are protected OBN, which are present at equatorial position OBN, which is shown over here when it is treated with another glycals, for example, not glycals, that is a what we can call it as a this protected one, this one, There is a double bond positive charge over there. The remaining OBN shown over here, and the part which we are going to get over here, this one, when they combine together, there is a OBN. Here once again OBN is shown over here, combining together, lot of mechanism over there. So I am not going to show that mechanism over here. So by combining these two together, the final product we generally obtain over here, this one, then O. Now, and this will be the reagent, that oxygen atom over here, this one, and finally this part we can write as it is OBN, then OBN, but here at axial position, that is a alpha position, this product are getting, and this, so OBN we can write as it is, and here hydroxy group, and here also axial position hydroxyl group, and this is one of the derivative, and which is biologically important one. This all about the point we have discussed so far. I think with this in the next time we are going to learn about the, what we can call it as a alkylation of reducing sugars. How do we define it? What do you mean by that? Alkylation of reducing sugar, that we will see in the next lecture. Let us stop today here. Thank you. Have a nice day.